Hello everyone and welcome back to the channel. Today we are diving into one of the most practical and creative skills in the world of large language models, which is prompt engineering. In this hands-on tutorial, you will learn how to guide powerful models like Llama 2 using smart prompt strategies without even fine-tuning a single parameter in the model. By the end of this video, you will know how to build zero-shot prompts, one-shot and few-shots examples, and specialized prompts for tasks like sentiment analysis, reasoning, and more. So whether you are a developer, data scientist, or just large language model curious, this hands-on is for you. So let's get started. So here is the notebook overview. We will introduce prompt engineering as both an art and a science, where your input controls the behavior of the model. We will explore different strategies like zero-shot, one-shot, and few-shots prompting, and we will apply them in real examples using Llama 2 7P chat. But these techniques works across other models like GPT, Claude, or any chat-based model. So the key takeaways here is prompt is not just writing questions, it's designing instructions that guide the model's brain to better generate results so that you don't jump directly to the fine-tuning step. To ground our experiments, we are using Meta's Llama 2 7P chat version model with 7 billion parameters fine-tuned for instructions following. So everything we do from here will be powered by this model. However, the code is adaptive so that you can choose the model of your choice. Before we interact with the models, let's load first the necessary Python libraries and silence unnecessary warnings. So we just keep the notebook clean and functional. So first, we will install the official Python library for Together AI, which is a cloud platform that hosts open source large language models like Llama and others. So let's run it. Here we import our helper modules like requests for HTTP calls, OS and user data, so we get the API access key for Together AI and the warnings to just keep things tight. We will use user data to securely store and retrieve our API key inside Google Colab. So if you click here on this icon, you will find that we have our Together API key stored in a secure place. So let's run this. Here is a quick primer on Together AI, the cloud platform powering our API calls in today's hands-on. It allows you to run open source models like Llama or Qwen at scale, fine-tune models on your own data, deploy private or managed endpoints, and get high performance with reduced costs. It's built for enterprise-grade use cases and it works great for experimentation too. So we'll be using Together's hosted version of Llama 3 for inference via API calls using our API key stored in Colab. So if you go to the website of Together AI, you will find all the models where you can request a dedicated endpoints or just use an available one, or what we call it serverless. And these are all the models available with Together AI. Once you log in, you will find a list of all models with either serverless models or dedicated, along with the price per million token. If you go to your profile, you will find where you can get your API key, where you can just copy it and then store it inside your Google Colab, okay? And give the notebook access to this key. Now we are making our first call to Together AI. We create a chat session with Llama 3.2 billion instruct turbo model. The prompt asks the model to analyze a sentiment here. And we expect something like positive, grateful, or supportive. This format uses OpenAI style schema. Okay, so from Together, we will import the Together library. We will initiate a client object or client instance from this class, from Together class. Then from this client, we will call the chat.completion.create a request where we will define our model to be the Meta Llama 3.2 3 billion parameters instruct turbo model. You can replace this line to specify the model that you want, along with the list of the messages, each message by its role. So this is a user message rule, and the content is analyze the sentiments of the following message. Hey Lena, I truly appreciated your support during the event, and I will receive this response inside a response object to print the message content in the first choice that we receive here. Okay, now let's run this. As you can see, the response is the sentiment of this message is overwhelming positive. The use of the phrase I truly appreciate indicates a genuine and sincere expression of gratitude. Okay, so the tone of the message is polite, friendly, and appreciative till the end. Okay, that's great. Now let's move to the next cell. Okay, now here we will set up the base URL headers and build a reusable Python function to send prompts to the API easily, like mini prompts sender toolkit. So I defined the URL for the Together API inference and the headers to include in the authorization part the Together API key, which we just grab it and store it into our Google Colab, and the content type to be a JSON objects. So let's run this cell. Now we are defining our main function to communicate with Llama model via Together AI's API. So we will define a function called generate Llama response. This function takes a system prompt, a user prompt, and the model, and the default model that we have here is the model Llama 3.23 billion instruct turbo. But of course you can change this when you call this function. Okay, inside the function, we define our payload that takes the model and the message with their role, system messages, that takes the system prompt that defines the context, and the user prompts, which is the user message that is the actual prompt or the actual instruction sent from the user. We send this via the requests and a post request, and we receive the response, define the result as a JSON object, and then we return the response to the color code. So now we built our own mini prompt engine. This function is your go-to tool for structured OpenAI chat interactions. You send two roles, system and user, and it returns the model thoughtful response. Great. Now let's build another alternate function. We call it generate Llama parameters, which is another function that calls the Llama model or whatever model that we have here. And I provided here a list of models that you could use to test their generations and compare between them. And the difference here is that this function will pass other parameters to the model, like the temperature, the maximum number of tokens, and the verb pause. Okay? And it packs all these parameters inside a data dictionary and pass it through the post request. So here we'll find the URL, the headers, and the data dictionary. And it returns the result. So let's run these two functions and build them together. And we will compare both in the hands-on. So as we see, this generate Llama parameters function is designed to call whatever model with parameters like temperature so that you can control creativity versus precision, and we will keep it at 0 for now. So we want a deterministic result, okay? But you can change this and tweak it and let us know how the output would look. Now let's move on to the first part of this hands-on, in-context learning, where we let the model learn from examples. Let's introduce a superpower of large language model here, which is the in-context learning, where we learn the model without changing any parameters. Instead of retraining the whole model in fine-tuning, you can just show 1 to 3 examples of how the task should be done, and the model will learn the patterns on the fly, or generate completions in the same manner as the examples that you provided. So think of it like showing a few math problems to a friend and asking them to solve similar ones. So we'll get to examples soon, but first let's start without them. Okay, so let's look at this cell here. So here we start with a standard instruction. We just give the task clearly and let the model handle the rest. This is also known as zero-shot prompting with instructions, where we do not provide any examples. Okay, so if we look here, we provided an instruction that says simply translate the following sentence to Spanish. And the sentence is, where is the nearest train station? So here we are calling the generate llama response function, passing the user system to define the rule and give a context to the large language model. You are a helpful assistant, along with the instruction followed by the sentence separated by a new line, and we print the response. So we clearly tell the assistant to translate the sentence. The system rule frames the assistant as helpful, and the user prompt gives the task. Let's run it and show the result. So the translation of the sentence, where is the nearest train stations to Spanish, is, and here is the translation, and here is the breakdown of the translation that is returned from the model. So this shows us how clear instructions alone can yield accurate results, even with no examples provided. So let's have another example. So here, this prompt skips the rule-based structure and uses the plain text to perform sentiment analysis. We pass it to the other function, generate llama parameterized function, and the model will likely reply with the sentiment. So the prompt is, analyze the sentiment of the following message. Hey Lena, I truly appreciate your support during the event, and I'm passing it to the generate llama parameterized function and print the response. Let's look at it. And again, the sentiment of this message is overwhelmingly positive. Use this format when your task is obvious and simple. Now let's test the model's intuition. In zero-shot prompting, we give no task instruction, just the patterns, and the model figures it out. So here we have no explicit task definition at all, just structures, and the model needs to know what it should do by itself. So this is useful when you want to test the model's general intelligence or compare between two models. The task should be obvious enough from the context, and you want fewer tokens. So this is also cheaper and faster. So let's give it a shot. So for example, if I'm sending dog, chien, cat, chat, bird, then the model should understand that it needs to translate or return the translation for the bird in French. Okay, so this is useful when your task is obvious from its context and we want to generate fewer tokens in a cheaper and faster way. So let's give it a shot here. In this cell, I defined a prompt called zero-shot prompt where I have English, car, French, and I need the model to complete this. So I took this prompt, passed along with you are a translation assistant as system message to the generate llama response, and let's print the response. And as we expect, it is voiture, which is car in French. So what we have done here is that we just gave the model a two-line example and asked it to continue the pattern with no prompt engineering magic, just pattern recognition. So this is great for cases where tasks are obvious from context and you want low token, fast and cheap interactions. So now, if we add a couple more examples, we will be doing a few shot prompting, which gives the model more context to follow. And that's what's coming up next. So for example, we can send English apple, French bomb, English house, French maison, English car, and French should be generated by the large language model. So let's try this also with our example of sentiment analysis. So the prompt is message colon, hey Lena, I truly appreciate your support during the event. And the sentiment, and I want the model to generate the sentiment. And if we run it here, we expect the sentiment to be positive. So as we see here, it's positive with emotion, gratitude, topic, event, and this is the context along with reasoning. Okay? So this is a minimalist zero-shot prompts where no system rules, no examples, just clear input patterns and a blank for the model to fill in. So this confirms that the model can infer task intent from the format alone with no extra help. Now let's move to the few shots prompting, where we teach the model with examples. And again, remember that with in-context learning, we change no parameters at all and are doing no training at all. Alright, here is where the prompt engineering really shines, few shot prompting. Instead of telling the model what to do, we show it how to behave with a few examples as I said, and this should work great, especially when your task is a bit more complex or the model needs more context. So let's try it with a unit conversion example. So in this example, I defined my prompt as few shot prompt, convert the following measurements from inches to centimeters, and I give it some examples from inches into centimeters, and I want the large language model to do its magic and generate what's the centimeters for this 15 inches. So I pass this prompt along with a system message that says or tells the large language model the rule or the persona that it should take. You are a measurement converter, and we print the result. If we look at the result here, let's run it again. It returns to convert 15 inches to centimeter. We can use the given conversion factor of 1 inch equal 2.54 centimeter. And then it shows me that it does some multiplications to provide me with the final result at 38.1 centimeter. As we see, we are giving the model a clear pattern, input, output, and after a few examples, we ask it to convert 15 inches. So since it knows that 1 inch is 2.54 centimeters, it gives us the results directly. So this prompt-based learning is at its core. And just like that, the model should follow your patterns and return the results. Prompting is all about showing patterns and setting expectations. No fine-tuning needed. Now let's see our example for the sentiment analysis where we will define the output format as well. So if you look here in the few shot sentiment prompt example here, we teach the model a pattern, and then we ask it to complete the next case where we ask it to respond in one word only. So it has the first example as a message and its sentiment as a negative sentiment, another example for positive sentiment, and then our prompt, and we are waiting for its generation, and we are giving it an instruction, respond in one word only, and let's run it. And it returns the sentiment of this message is positive. Now let's try a bigger model, Llama 2 70 billion parameters chat version, okay? And pass the same prompt and just defining respond with only positive, negative, or neutral. And we pass this prompt to the generate Llama parameterized function with the prompt and the model and the big model, and let's see the output. As you can see here, when we switch the gears into a bigger model, it is getting more precise, okay? And the result will be, or the generation will be positive with no extra text. Okay, so this time we tell the model to choose from a fixed set output, positive, negative, or neutral. Output should be one of those with no extra explanations. So using large model may increase consistency and reliability, but at a higher compute cost. Okay, now let's switch back to the smaller model, but we are adding stronger formatting instructions. So we are asking the model to respond with either positive, negative, or neutral, and we provide other examples, okay? And let's try the model, and let's run it. So as you can see here, being very explicit and clear, only output one of three labels, no commentary, no fluff, gives us the result, which is the sentiment is positive. But unfortunately, it added some extra hallucinations or examples or extra chatting. And that wraps up few shot prompting and output formatting. Now let's move to our next section where we introduce to you the rule prompting, where we set the stage for the model. And here is where the fun starts. Instead of just giving a task, we assign the model a role or a persona. For example, you are a history professor, you are a career advisor, you are a fantasy storyteller. So why this works? Because it guides the model tone, vocabulary, and structure, just like an actor putting on a costume. So in this example here, we are asking the model to become a Shakespearean poet and talk about artificial intelligence. So the role prompt is you are a Shakespearean assistant and the user asks, tell me about artificial intelligence. So if we run this, we expect a weird English language, and as you can see here, good morrow to thee, kind sir. And it writes English that I even do not understand. So this is how the response changed completely using the same model based on who the model is pretending to be. And that's the magic of role prompting. It transforms not just what the model says, but how it says it. So this is super useful for building chatbots, storytelling tools, or fun conversational agents. So let's take it further. Now we are turning the model into a motivational speaker. You are a motivational speaker who shares wisdom in poetic and inspiring style. You respond with clarity, warmth, and hope. And this is the prompt. It consists of this role or persona and how can I respond to this question from a colleague? What does it mean to live a fulfilling life? And we can see that the model has generated a deeply human generation or completion. What does it mean to live a fulfilling life? So with this poetic rule, the model will likely reply with something heartfelt like what you can see here. So this prompt style is perfect for life coaches, support apps, or personal journaling bots. Now let's move on to the chain of thoughts prompting, where we teach the model to think out loud and think with us instead of thinking for us. So this is a powerful technique called chain of thoughts promptings, or COT. So instead of jumping to the final answer, we ask the model to think step by step, just like you would do in math class. This will improve the accuracy, the logical consistency and reasoning, and transparency in reasoning by showing and explaining how the result was generated. This boosts performance on tasks involving math, logic, and multi-step decisions. Okay, so this is like asking the model to show its work. So let's look at this example. So the prompt is, if a train travels 60 miles in 1 hour, this is our question, how far will it travel in 3 hours? And the answer, let's think step by step. So I'm asking the model to show me how it reaches the result in a step-by-step reasoning. And this is the rule that I'm sending as a system message. You are a smart math tutor, passing it along with the prompt to the generate Llama response that we have declared at the beginning of this notebook. And let's run it again. So the answer is the train will travel 180 miles in 3 hours. And this is how it broke down the problem and reasoned it step by step, showing the distance equals the rate by the time, then the distance 60 miles per hour times 3 hours until it reaches the 180 miles. This approach works wonders in tutoring apps and math solvers and gives users confidence in the result. It also allows the model to reduce errors and build trust in its logic. So to make the chain of thoughts even more effective, let's fine-tune our instructions. So for example, instead of just saying think step by step, we can say please explain your reasoning before answering. And this subtle change leads to even more thoughtful responses. So if we look here, how we refine the prompt here, we are having a prompt that is, if there are 12 apples and 4 people, how many apples does each person get? And please think step by step before answering. So I'm asking him, don't jump to conclusion before thinking. And this is the system message. You are a patient problem solver. And let's see the results again. So step by step. Step 1, identify the total number of apples. Step 2, we identify the total numbers of people. which is 4, and then we divide the total number of apples by the total number of people, and it shows me how it built this equation. So, and this is how we started to thinking and what is defining the strategy that it needs to get to the results. So although this is simple division task, but we want the model to be transparent. So the results will be more clear, concise, and trustworthy. So this is great for educational use cases, from tutoring apps to explainable AI assistants. So next, let's explore the translation prompts, summarizations, and few advanced tricks using real-world contents. Before jumping, let me show you some advanced tips where we ask the model to separate the reasoning from the final answer. In many real-world tasks like legal documents, tutoring, or chatbot agents, it's helpful to separate the reasoning from the final answer. So let's level up our prompting game. So we will make the logic transparent, and we will go downstream systems like APIs and user interface, a clean value to extract. So in this prompt, this is our questions. A toy costs $15. If you buy 4 toys, how much will you spend? And we ask the model to explain its reasoning first, then state the final answer at the end so that we can extract it programmatically. So if you run this, you can see that it shows the reasoning and then it splits the final answer as a separate answer so that you can extract it using your code. So this is like some structured labels like final answers when parsing models outputs programmatically. And all what you need is just to use regular expression or code to extract just the number, making this prompt automation friendly. Here is something else that many folks overlook, which is the order of instructions, which seriously matters here. Large language models generate text from left to right, token by token. So your instructions order affects everything. So saying think first, then answer works well than answer first, then explain, because this might skip reasoning entirely and provide us with a wrong result. So if we look at this example, this is the questions. If a car uses 2 gallons of gas per hour and drives 5 hours, how much gas does it use? So first, think through the problem carefully, then after you finish thinking, and only then, so we are confirming and being strict about it, give the final number of gallons used. Passing this prompt with a user message that says you are a thoughtful, careful AI assistant to the model will give us the reasoning followed by how much gallons the car would use. So we are explicitly telling the model to think before jumping to the answer. And these patterns keep your responses predictable and thorough. And that's exactly what we want, the reasoning plus the final answer. So this is perfect for trustworthy results. Now it's time for a quick reality check. Large language models don't actually think, they just predict text token by token, and that's why we call them tokens generators. But when we prompt them to think step by step, we give them the structure or a structure that simulates reasoning. It's like saying, pretend you are solving this like a human would. And it works across math problems, logical chains, multi-turn dialogue agents. So if we look at this example, we have 30 people going to a conference. 3 vans are available. Each van fits 6 people, and 1 person has a motorbike for 2. Can we transport everyone using only these vehicles? First, think step by step, then provide a 1-word answer, yes or no, along with system message telling the model that it's a group leader to generate a response. And let's look at the result. So the answer is no, but it reached this answer after breaking down this problem. So far we have learned role prompting, chain of thoughts, and format control. Now we can combine these techniques and stack them. Why? because layered prompting gives you more consistent, structured answers, like having a helpful assistant that you can trust. So let's combine this together in the following example. So let's look at this combined prompt. You are a helpful teaching assistant. Answer the questions and explain why. And the question is, why do birds migrate in winter? And I'm expecting the answer here. So I'm passing this combined prompt along with the system message to the large language model to get this persona. And let's look at the answer. So here is an answer where we combined a friendly persona, a clear questions, and a structured prompt asking for explanations. So this is what it gives us as a result: the food availability, the harsh weather, the breedings and reproduction, predator avoidance, and evolutionary adaptation. Great. Now let's get a little creative now. So prompt engineering is not just for math or factual question and answering. It's an incredible tool for storytelling, gaming, and more. With the right setup, large language models can help generate story openings. They can write dialogues for characters in games, and even assist in creative writing or screenplaying drafts. So let's test that next in this cell, where we ask the large language model to be a fantasy storyteller, and we ask it to begin a tale with the following lines. In the heart of the forgotten forest, a single lantern flickered, and we are giving it a persona that it is a master of fantasy storytelling. And let's see what's the output here. So here we are combining a rule prompt, assigning the model a persona with rich, vivid input, and the model is told to be a fantasy storyteller, and then we seed it with the first line of a story. Why this matters? This style of prompting helps models to maintain tone, stay on theme, and stay creative. Okay, and if you look here, this is what the model came up with. This is a full tale of the story to tell. Beautiful, right? Now we can use this in creative tools, entertainment apps, or narrative generation pipelines. Now let's switch gears a bit now and see how the model handles factual knowledge. Okay. Here we are testing how well the large language model can recall details from its training data. So this is especially useful for educational tools, apps, and general purpose assistants. So let's ask a questions and see what happens. So for example, the factual prompt is, who won the Nobel Prize in Literature in 2021? And we pass this prompt to the large language model, and the result is the Nobel Prize in Literature for 2021 was awarded to Abdulrazak Gurna. Now, if I change this to simply who won the Nobel Prize in Physics in 2024, the large tells me that I do not have information about 2024 Nobel Prizes. My knowledge cutoff is December 2023, and I do not have real-time information. Okay, so the Nobel Prize until the end. So it means that the model did not have the sufficient knowledge to answer my questions. So it depends on the model training's cutoff date. So let's talk about that in the next section. So on the other hand, the model was trained before this award was announced. So it may guess incorrectly or provide an outdated answer. Now here is a great case study. Let's ask the model about something recent, like the 2024 Wimbledon Championship. So who won the Wimbledon Championship in 2024? And the persona is, you are sports experts. And again, it will tell me that it doesn't have this information. So without any context, the model may guess incorrectly, admit it doesn't know, or even worse, and sometimes it hallucinates and made up a name. So if the model doesn't know, he might generate answers that does not exist. For example, who won the 2024 Men's UEFA European Championship? And it can tell me that this championship has not taken place yet, although that we are in 2025. So to handle these situations, we need to inject context in the prompt. And this is great for recent events, for company-specific knowledge, and custom workflows or datasets. So let's define our context here. So back to the Wimbledon Championship example, we provided the context for the model that tells the model who won the Wimbledon Championship. So the prompt will consist of this context, then who won the Wimbledon Championship in 2024, and let's pass it along with the persona for the large language model as a sports expert who keeps up with the latest news. And it will provide us the results for the men's singles and the women's singles from the context that we provided. So this is context injection in action, one of the most powerful prompt engineering techniques. And this is the basis for the retrieval augmented generation, where we select the relevant or the top relevant context from our data sources or knowledge bases from different data sources, including vector databases, and provide it as context along with our prompts. So that's what we want now. We don't need to fine-tune or retrain a model to just get the best results. All what we need is just to give the model the facts in the prompts as context. And here is the context for the Nobel Prize. So this is the context, passing it, and we are asking who won the Nobel Prize, and we get the answer from the context. Great. Now, prompt engineering is amazing also in business context, where you can generate emails, generate reports, or even summarize long documents or reports. If we look at this example here, we ask the model to write a professional email to decline a job offer due to a better opportunity while expressing appreciation as well. And this is a good professional way where we use large language models in daily tasks. So this is the persona. You are a professional HR assistant, and this is your email prompt. Show me the email. So this email should be thank them for the opportunity, but after careful thought, we have decided to accept another offer. So this is perfect for HR relationships. So it's good also as a productivity tool or a job seeking assistance. Summarization is one of the most practical large language model skills for emails, articles, and reports. In this example, I'm sending a text to be summarized, okay? Along with the prompt, our summary prompt will be summarize the following text and giving a separation between my instructions and the text that I want to summarize it, or even put it into single quotes or taggers or HTML tags, will provide the large language model with the structure to what text it needs to give attention to. So we pass this along with the persona as you are a professional summarizer to the text, and we get the summarization for our text. So Llama models help humans to interact with machines and are used in business educations and more. Now in the next example, we test summarization on real-world dense email, like one from the team strategy meeting, where we need to ask the model to extract the key decisions and the architectural plans. So if we have a long email like this one, I can just send it along with a clear instruction, summarize this internal strategy email, and extract the team's key AI decisions. What architectural choices were made for the chatbot and legal summarization use cases. And along with the email, separate by a placeholder for the email so that the large language model would understand where the text to be summarized starts at. So if we run it, we will get these are the key AI decisions and these are the architectural choices. Wow, we have come a long way today. So let's take a moment to summarize everything we have covered in this hands-on tutorial on prompt engineering strategies with large language models. We explored the power of role prompting, zero-shot and few shots prompting examples, chain of thoughts reasoning for improved answers, context injection to handle real-world facts, and using prompts for summarizations, email drafting, storytelling, and even more. So remember that the main takeaway here is that prompt design is the model. So what's next? Still curious? You are in luck. We have got more coming your way. But before that, if you enjoyed this tutorial and learned something valuable today, don't forget to like this video if it helped you, subscribe to the channel for more real-world AI machine learning tutorials, comment below what's your favorite prompting tricks so far, and check our GitHub repo to get this notebook and tweak it as you need. Final word here. Thanks again for learning with us. It has been a real pleasure for me walking through these strategies with you. So whether you are an AI researcher, developer, or just generative AI curious, keep prompting, keep experimenting, and keep building smarter systems. So until next time, share this with a friend, watch it again, try out your own prompts and build something cool, explore more advanced topics like prompt tuning or fine tuning. Keep experimenting, keep learning, keep prompting, and thank you for watching.